are, oh, okay, there, I got a message that the recording was in progress. I got it. So I'll be sharing my screen for the presentation that I have. Here we go. So here's the proverbial question for and not, if everybody can see this. Okay, great. The other thing is that I might be skipping over details that you need to know for your own practice and knowledge. So please interrupt me or raise your hand or sign in Annemieke by chat that you want to ask a question. This is very much to me meant as an open hands-on session. And there's no reason why you would hold back any questions. To start off, version control and management. Why would you want to use version control and management? Well, probably you all have the experience of sending around Word documents or other types of documents and having a number of people working on the same document, or rather on copies of what should be the same document. And if you are in the unlucky position that I had a few years back, you might have 4 or 5 people working on different copies of that document, and you are the one that is sort of appointed the task of merging all the different variants of the document that comes into existence. And this is a error-prone and tedious task, of course, that you would rather not do, and rather you'd have people working on one document, one set of data, and one version of that data or that text, so that all the changes, then additions that people make, are sort of merged together automatically and kept under check and control. That's specifically the task of any version control and management. Of course, you want to be able to track changes over those versions, and you want to prevent conflicting changes. And as may be clear, this is very useful if you're working with a large group of people, or even if you are only working with 2 people on the same document. Also, version management and version control comes in quite handy a few years later when you have left a project. I myself returned to some projects, some coding projects in this case, across years. And usually I might have switched machines even. I might have gotten myself a new laptop, and that code might not be on my machine anymore. So in that case, the version management and control system also functions as your working archive. Because it's offloaded to a remote location, you are ensured that you can't lose any stuff that is important to you. Also, version management usually keeps trace of all the changes that you made. So you have the different versions available. You don't only have the last version of a certain document. And when you return, especially to a coding project a few years later, or a data encoding project, that trace of changes informs you about what you were actually doing, and you can start making sense of why the code or the data has the format that it has in the latest version. So all those things are very good reasons to try to use a version control and management system. Now, there are lots of types of version control and management systems. One that is most often in use is that people will use, for example, the file name as a way of trying to indicate what that particular file or set of data was for, what version it was, when it was made, etc., etc. And when you would look in people's documents folder, you might see a thing as you see here in this comic, in this cartoon. And well, for sure, I have used version management like that. I'm still using version management like that in some cases where actually the document or the file is not that important. But be assured that this is really, really bad practice. So If you're still doing this and you're doing this on important files, that's a good sign that you might want to look into better systems of versioning and keeping control of the versions of your documents. So when we are doing version management with Git and GitHub, there are actually two pieces of software that are important to us, or two digital objects that are important to us. Git and GitHub are actually not the same thing. Git is a piece of software which was created by Linus Torvalds, the big person behind the Linux operating system. And he created that software because at the time, in 2005, he was managing all the different versions of Linux that were being created and that were being worked on by a lot of volunteers and open source programmers to develop this open source operating system. And there were literally thousands of programmers working on that code base. So he really needed something that would sort of keep track on where they were. Git officially, well, there is no officially solution to the acronym, I believe, but most people, and also Linus Torvalds, tend to think that it's a global information tracker. Linus Torvalds himself also said that when Git is not working, you can also solve the acronym as a goddamn idiotic truckload of trash. So depending on how well it is functioning for you, there are several ways of solving that acronym. Now, Git is the piece of software that's running on your local machine, on your personal computer, and that keeps track of the versions of certain data sets or documents or files with programming code on your machine. Now, Git is supposed to communicate the various versions of those documents with a remote repository. And that remote repository, in our case, comes in the form of GitHub. And GitHub is actually a web server or a web service. There's a lot of web servers actually running GitHub. And they are, of course, not your machine. Those are remote machines that serve as an archive, as a remote repository for the documents that you want to version control. So GitHub is a web service that actually runs Git on their servers. And using Git on your local machine, you're going to communicate with those services. Git is your local tracking service. It keeps track of files in any folder that you want to keep track of, that you have files in that you want to be version controlled, and it's running on your computer. And Git acts there as a local repository. So this has nothing to do with remote archiving, remote systems. That's all local on your machine. So once you tell Git that it should track the files in a particular folder, it will create a local repository where it keeps the versions of all those files in that folder in that local repository. You can really see this as an archive box on your computer, keeping track of the different versions of the documents in that particular folder. GitHub, again, is a remote web service. You can see that as an off-location storage archive box where copies can be held of the local repository as well. So how does this work? If you're working together with people on the same document, then everybody will have his or hers local archive, local repository, where there's already local version management for those particular files or sets of data. And all those people can communicate their version of that particular file to the central service, which is running in this case on GitHub. So you can imagine that if a lot of people are working on the same document, that this version management from the perspective of the centralized repository is quite a complicated and complex operation. And the operation and keeping track of all the merges and changes, etc., that's what Git and GitHub are really good at. And that's the error-prone and tedious task that we want to outsource to GitHub. Okay, this has a number of this setup, which is typical for any automated version and control management system. Has a number of particular consequences that you should be aware of when working with these kind of version control systems. That is that you might think of the document on your local machine as the master version or the authoritative version. But actually, that's not true. In the case that you're working with a remote repository where people are also adding changes and working on a document, that remote document, that's the authoritative version. And nobody is able to see what you're doing locally to a document. So you should remember that, because if you're working together, it's important that especially the centralized version, the centralized document, the remote version, that is in a good state, that's in the state that you want it, and that is in the state that you want your colleagues to work on. Because everybody can see the remote version, and again, not your local version. So local changes that you make and that you write and save are only stored locally, and they are not visible to other people until you check those changes into the centralized version. Okay, so for the practical bit, we are going to work with Git and GitHub. And Git is one type of software to do version management, but it actually comes in a lot of different forms and shapes. So there are graphical user interfaces that you can combine with Git. One is, for example, a graphical interface that is built into the Atom code and text editor. But there's also a specific graphical user interface made by Git itself. And it's always fine to use these graphical interfaces. However, I'm using the command line controls today because they give you the same uniform picture everywhere, whether you're working on Windows, whether you're working on Linux or Mac. Whereas all the graphical interfaces can look different on different machines and depending on what software you are using. So just to have that uniform view of how Git operates and what commands you can use, I'll be using the command line for this session in any case. Okay, so I explained that there's a local repository run by Git, and there's a remote repository run on GitHub. And then the question becomes, how do you actually talk between those two Git position or Git repositories, you could say. And this is where the commands push and pull become important. If you would say on the command line Git push, it means that Git is going to push all the changes that you have locally in your repository to a centralized repository. The other way around, if you would want to update, if you want to integrate the changes that are remotely stored on GitHub, and you want to pull these into your working situation, your local working situation, you would say Git pull. Now, you want to know something. It can be sort of, unsettling, the idea that you might have a local version and there might be a completely different remote version, and you don't sort of want to mess up stuff, of course. Now, Git is going to actively resist you in messing up. That's the good thing about Git. But nevertheless, one command that will be very helpful always in sort of preventing you of strange thing happening, or you yourself doing strange thing, is the Git Status command. So if you would type in on the command line Git Status, it will always give you a short overview of the situation locally and remotely, on what changes there are. So my personal practice, but I know from experience that a lot of coders and programmers and data workers do that, is to overuse essentially Git status. So before you do a Git pull or Git push or Git fetch, we will get to later, usually I will also every time do a Git status just to check what is happening, what is going on. Because the Git status will also tell me if something's wrong, if something's strange. And then I want to be indicated that something strange is going on. Okay, so we have Git pull to pull in remote changes. We have Git push to push towards the remote repository any changes that we might have locally. We have Git status to see what's going on. And then there are two more important commands. That is Git Add. Git Add adds new files or new files that we have made locally towards your local repository. And this is quite confusing, right? Because you have a working directory, that's the folder that you're working in, where the files are that you're working on. But those files are not in your local repository when you create a new one. So you use Git Add to ensure that the local repository is keeping track of a new file that you create. And then we have Git Commit. If we have actual changes with Git Commit, you will commit these changes to your local repository. Okay. So, oh, yeah, just in between, a side note, why are we using GitHub? Well, essentially because it was the first one that was easy, free to use and had a very clean interface and everybody liked it. But GitHub is certainly not the first version, remote version management system, nor is it the only one. There are very much alternatives as well. Very popular these days is GitLab, but also, for example, Bitbucket or SourceForge or Launchpad. It's all fine to use any of these. Essentially, they all are doing the same thing, but GitHub is still the largest one around. It's still also free, and it's very easy to use. So I would say that use a version control and management system rather than to worry about which one you use, but using not one would be the wrong choice in my view. But just to say that there are more ways to use a version and control management system. Okay, so that's all theory, and it might have been confusing. You heard a lot of commands already. So let's do a first practice run. If you want to, I will basically do this as a type along. So you can follow what I'm doing and you can try to replicate it while I'm doing that on your own machine. For that to succeed, there are two assumptions, which is that you have already created an account on GitHub and that you have installed locally on your machine the Git software. If you not have done so, don't worry. You can still, I think it's still useful for you to see and experience how I'm using Git and GitHub, but it might be useful to then try it yourself while you're looking at the recording of this session. Okay, so let's create a, oops, sorry, my tea shouldn't topple over there. There we go. Let's go to GitHub and create a new repository. So in my case, I will go to GitHub. Is that readable? Should I probably should enlarge that a bit, I guess. Is that generally readable? Okay, good. Okay, so this is the place where I land when I go myself to GitHub. You should, if you have made a GitHub account, you should see something of a similar view. Usually what I like to do, there's a new button over here to make a new repository, a new remote repository in your GitHub account. But the page, the view that I like best is actually my profile page. Because this gives me an idea of which repository I have been working on lately. It has my nice logo, etc., etc. That's just a personal preference. Anyway, we are here going to create a new repository. So create new repository. That's the easy thing. Now GitHub will ask you a few questions, and they are a little important to consider. First of all, there's of course the repository name. What shall we choose?
Box.
Sorry? No, I will not do that. Let's simply call it Git webinar. The description is purely optional. But the next one is actually pretty important. You can have public or you can have private repositories. So this is about the remote repository. Your local repository is, of course, always private. It's only for you. But remote repository, you might want to open up to use of other people, or you might want to keep it private. Public is really public. It means everybody in the world that has a GitHub account, or even those people that don't have a GitHub account, can view your data, can view what's inside of your repositories. They can't change it, but they can view it and they can download it. So public is really very public. Private is really very private, but you still can appoint other people to be able to view your data and to download your data. But that downloading and viewing and collaborating is then restricted to the persons having that login, of course. If they would share that login with others, you know, there's always ways to get around safety and security issues, but normally you would would want to work with people that you trust, of course. In this case, I don't care. Everybody's allowed to see this, so I'll be ticking the public box. Then there are three things that you might think a little bit about also when you're creating a repository. There are always three important files. Well, how important? Useful files, I would say. First of all, there's always a README file. And the README file is, I would say, good practice to add, because the README file is also the file that will be shown on the home page of this repository. So whatever we type into the README file, which is a plain text file, will be the first thing a person sees when he or she goes to your repository. So that might be a little description of what's in the repository and why it's there and who's supposed to work on it. So that is basically the front page of the repository that you're working with. So that's always useful to add. It's always useful to put in a description, even if it's a one-liner, just to sort of indicate what's happening here. I also always choose a git ignore, because, well, if you're like me, you will have stupid little files around where you keep notes and where you keep private conversations or whatever you might have, or, you know, there's still that file that's not really ready to go. And you can add the names of those files that you don't want to be uploaded to the remote repository. You can list those in that git ignore file, which is very helpful, because you might have a to-do that's really for your personal use, and you don't want it to be end up in the remote repository where everybody can see it. So in that case, you just add the name of the file, which might be to-do, the .text. You add that to that git ignore file, and it will be completely ignored for version management. Useful and handy. Depending on what languages or encoding languages that you are using, there are all kinds of ready-made git ignore files. So suppose that you're working with a Python project, you can select Python and it will automatically already make a git ignore file that has the most of the well, rubbish, I would say, files that you don't want to end up in the remote repository locked out from version control. For example, Python will create all kinds of cache files, so temporary files that it's using when executing Python scripts, but they are really not useful to share with other coders or with other people. So those get ignored. So that might come in handy. So you can always look if there's a particular ready-made file that is of use to you because you're using XML or Python or Java, etc. Then the last one, not unimportant to consider, especially when you're working with a public repository, is what rights do you want to convey to the users of your code or encoding or your data? Now, I'm always very liberal, so I tend to use the MIT license, which basically said, hey, you want to use this, go ahead, you may use it commercially, but I'm not responsible. You know, if you're going to sort of blow up the government with using parts of my code, that's your choice, but I'm not responsible for that. But there's also all kinds of other licenses. So if you want to be somewhat more exclusive about certain kinds of data, etc., it's useful to pick a license that will sort of guarantee that for your data or your code. Again, there are lots of choices. I'm not going to talk about these all, but suffice to say that you can check out what these licenses determine as to the use of your code or data. Okay, so when setting up a new repository, you do this once, but it's a routine that you should think a little bit about to get a clear starting position for your repository. Okay, let's create it.
It might be useful to mention that you can always switch between private and public, but if you switch from public to private, then you have no idea whether someone already copied it in an earlier phase. So you're out of control there. But if you go from private to public, then obviously nothing really serious happens, except that other people can now visit your repository.
Yes, thank you for that. No, that's important to mention indeed. Switching, you can always switch from private to public and from public to private. But once code or data has been public, you know, information wants to be free. So probably robots have been scouting your repository to make copies already in all kinds of internet archives. And maybe that's exactly the thing that you want to happen. But just be warned that, yeah, public is usually very public in this case. Okay, so what we have now is that you see that in my personal account, there's now this new GitHub repository, which is called Git Webinar. And this is actually the contents of the README file. And here you have a list of files that now are in this particular repository. And you can, for example, if I click on the README file, you see that indeed this is just the contents of the README file. And exactly that contents is on the front page of my repository. Okay, so now basically we have that archive box at GitHub. Well, great, fine, but how are we going to use that locally? So there's another green button. It's nice of GitHub that they have decided to color all the important buttons green. If you ever see a red button on GitHub, by the way, do pay attention, because a red button is usually something like, do you really want to delete this repository? And you might want to think twice about that, of course. But be assured that they thought well about this interface, and yeah, things that are good to do are green, things that are bad to do are red. Anyway, we want to use this green button because it gives us the actual URL to this repository, and we are going to need that if we want to clone that archive box on the remote repository as a local archive box and folder for that. So I'm going to copy this URL there. I copied it. It's now on my local clipboard. And what I do now is I start up my terminal. Are you all still seeing this terminal screen? Okay, thanks, great. So this is what on Windows is your command, you can access your command line by typing command in the run or execute box. Actually,
it's CMD.
It's sorry, yeah, I was thinking that was wrong. So if you
so you right click on your Windows logo, and then the third option is you first have desktop shutdown or sign out, and then you have run. You click on run, and then this little screen opens and it asks you what to open, and you click in CMD. I also put that in the chat, CMD, and then you click OK, and you will get, well, contrary to your screen, you will get a black screen which shows you exactly the same info as he now shows.
Yeah, yeah, I can turn it to black as well, but it's basically what you're now doing. You're on the command line, as it is called. So you're basically talking to one of the most basic levels. You are talking to your machine. So not using the Windows interfaces or the Mac interface with the nice colors and icons, but this is all text. This is all text commands. So now I'm in my personal documents folder. I think. Let's see. Yes. So this has a lot of subfolders that you see here.
You might want to make this a bit larger.
Oh, sorry. Yeah, of course. That's hopefully viewable. I'm just going to make a temporary directory. There's nothing in here. So all I've done right now is making a folder, a directory on my local machine that I can use to clone this repository in. Usually I do this in a folder called workspace, where I have a ton of repositories and code libraries, etc. But because there are so many files, it would just be confusing for you, I guess. So that's why I made a clean directory. Wherever you, whatever location you choose on your machine, that's really up to you. Just as long as there is a folder, a directory somewhere that you know of where you want to start cloning this remote archive box. But that's exactly what we're now going to do. So I'm going to do a command git. If you want to start using a repository, a local repository, as a clone from a remote repository, the first thing what you do is in that folder, you type git init. Actually, I realize I am wrong, because if you use the git clone command, it will already do this for you. But it doesn't matter. It doesn't hurt to do it twice, as it were. Anyway, so the important thing to do is, what I now did is I type git. So I call the git program. I say that I want it to clone the repository that's at that remote URL. If you paid attention, you would notice that this is indeed just the URL of that remote repository. So let's see if this works. Oh, there we go. You see that it tells us that it's cloning into Git webinar. It tells us how many objects there were in the remote repository. Apparently there were 5 files. Well, it's probably correct. It was 100% copied, etc., etc., etc. So this gives you some information. And if something would have gone wrong, we would have seen an error statement and explaining what went wrong, and probably some helpful information. Anyway, if I now look what's in this directory, we see that indeed there's now a Git webinar folder, and that contains, if I go to that folder, you'll see that let's put it like with a little bit more information. So you can see that indeed there's now the README file, the license, and the Git ignore file, and some Git control files. If I can show you now the contents of the README file, and you see that this is a remote repo for the Huygens webinar. And in the background, you see that's the same as what's on the remote location. We now have a local archive box, you could say. So you can now choose any text editor you want. You can choose any other editor that you want. You can store data, other files inside of this directory, this folder. And we can then add that to our version control management. These two folders, this folder and the remote repository are now linked by this GitHub system, as it were. But we still have to control how we work with that, of course. So let me just start by making a change to that README file. Again, I'll do this. I'll do this with the VI editor. That's a complete command line based editor, but really you can use any editor you want. Even if you would want to put in Word files, working with Word on them, you can. Version control on Word files might be a little bit awkward though, but the versions will be managed for you. So you're not tied to any particular editor or anything, just as long as you can actually change the file. So let's make a little change. This is a little change to the remote repo for those. So we now have a change. I'm writing that to the file. Did I actually write that? I think I did. There we go. Let's just check if it changed. Yeah, this is a little change. So if I now, here's our friend Status. So again, whatever you do, whenever you are going to use commands for Git or GitHub, Git Status is your friend. And you can see it's my friend because it tells me in nice red letters, hey, you have a modification, something changed. So it has detected that there's a change in the README file, which is of course correct because we just changed it. Okay, and yeah, that's a change that we actually want to communicate to the remote repository. So there's two things that we need to do in that case. First, we want to commit the change. We first want to say to our local Git instance, our local repository, yes, this is really something I'm behind. I think this change is important. It should be committed to the archive box. So I'm going to say commit, commit, and I can add a little message. You can always add a message. Is a good thing to do. I don't have any very useful information on this little change. Well, as an example, I guess. There we go. Usually what you do is just give a one-line statement. It's both for you and your collaborators just to know what is this change about. Okay, so it could be as simple as new version, but usually you want to give some more content, like I added section X or I added this functionality. You don't have to make all long epics from those changes, but it's useful to give a one-liner on indicating what you did.
Can you briefly explain what the -A and -M mean?
Yes. Git commit, the Git commit is the command part. Git is the program. Commit is the indication to the Git program that we want to commit the changes that we found. The -A ensures that any new files that are found are also added to the repository. And the -M you use to indicate that whatever follows the -M is that little message on why you made the changes or why you are adding changes. Again, it doesn't need to be a novel, okay? Just a simple indication why those changes are there. Some people also choose to not use messages, but normally it's very useful to do.
And in this case, you get an error message because you forgot Git Add. Apparently. No change added to, or do I overlook something?
No, that's, oh, sorry, now I see what you mean. You mean this one.
Yes.
Okay, yeah, but that's the output of the git status command that I used. This is I used git status over here to see what the status of my repository and local working tree are, and only here I say do actually add those changes or integrate those changes. So I think we're all right. Well, in any case, git status will tell us. And there we go. So indeed, now we get the information that our branch, this our local working tree, our local directory that contains the files that we want to be version managed, is now one commit ahead of what's remotely available. So we do want to now push those changes to the remote repository, the centralized repository everybody can view. But just to see that indeed that there's a change, if we reload this page, you see that there's no change. This is a remote repo for the Hybrid GitHub webinar. You know, it's still the old version, as it were. But locally, we see that's already changed. There's a little change to the remote repo. Okay, so there's a difference. And Git indicates to us that we need to push these changes to the centralized repository if we want them to be integrated in a remote archive box. So that's exactly what we're going to do. And I'll explain. Okay. Oh, sorry. There we go. This is the command that we use. And this needs a little explaining, I guess. Again, Git is just a call to the program. Push, as I explained in the theory part, is the fact that we're giving the command to push any changes that are locally to the remote system. On the remote repository has a particular name and a particular indication, but you might be working with different remote repositories actually. Usually, in that case, you might need to use something else than origin, because you then need the label for that other repository. Usually you don't have to worry about this, because normally you will work with just the default repository, as it were, the repository that you make yourself. And in that case, you can always just use origin. Now, the last part is the so-called branch. We won't be going into forking and branching, etc., all the more subtle ways of version management and creating different versions of particular data and files. But main is yeah, well, actually what it says, it's the main branch of your remote repository. That version of the documents and the data and the repository that is authoritative, that is leading, that is the one that you basically want to be the primary version. So usually this is what you say: git push origin name. There can be various reasons why you would want to use a different command, but those are concerned with branching and forking of projects, and we're not needing that right now, and we're not going into the details of those more advanced uses of Git and GitHub. So this is the way we push information to the centralized repository. And again, it summarizes what it's done, how many changes there were, etc., etc. But the important part is that if we now notice that this is still the old version, and now if we reload this repository, hey, we see that yes, that has changed in accordance with the changes that we had locally. So now the local repository and archive box and remote repository and archive box are again in sync. And we have a system that's nicely having those different states and versions. You see that there are, this repository has now 2 commits. If you remember, we just initialized the repository. So that was a commit, and we made a change. So that's 2 commits. And you can also get information. And these essentially are now the automated track record of the changes that we have. So we still have the initial commit, and it gives information on what the data was at that moment. And we can also, if we want to, we can always return to that state. So inbuilt now you have really version control, because if for some reason you want to retrieve the older version for some reason, you can. There's not all that time left to go into these details, but you now have the basic commands that you need: git push, git pull, git clone, git status, git commit, to start working with version management, and to ensure yourself that you have a remote archive of all the versions that you're working with on data. There are all kinds of more subtle commands to retrieve older versions, to start working on complete versions of the project, to allow other people to work with you, etc., etc. But those are all kinds of a little more advanced commands, so we won't have time to go into details about those commands.
I guess that when you're working with on a project with multiple people, not everyone can push to main. Is the question? As the owner of the repository, you can probably have control over who can do this or who doesn't. Yes,
that's a thing that is good to treat still in this this short webinar, I guess.
And maybe also briefly show how to pull the new information when someone else has pushed.
Quite right. Yeah. Okay. So let me first indeed make a change in the remote repository and show you how I can pull those over to my local repository. Okay. So this is that README file. And actually, I can edit this file within the GitHub remote environment. Bad practice, okay? Never do this. Well, of course, you're at liberty to do that this way, but be notified that you shouldn't, and that it's bad practice, and usually this is not the way to change files, okay? But you can. And just for demonstration purposes, I'm adding a sentence to this file. But again, normally I would never do this in this way. Anyway, where's my commit changes? There we go. There we are. And you see that that sentence was indeed added to the file. Again, not the way to do this is just imagine that somebody neatly on his or her local machine made this change and committed it to the remote repository. Then now on my local machine, I would want to check and find out if there are any changes when I start working again. So what you normally do is git fetch. Git fetch fetches the changes that are available in the remote repository. It doesn't actually change your files locally. It just checks whether there are changes and whether there is a reason why you would want to integrate those changes. So if I now say git status, oops, it tells me that my branch, is my local situation, is behind actually by one commit. And that's correct, because we did one commit on the remote repository, we made one change, and that change is not available yet locally. But Git does have that information because we did Git fetch. And probably before we want to go working on our local file, we want to have the changes that were made by our colleague or friend that was integrating those changes on the remote repository. So in that case, we say Git Pull. And now we get a little indication of what changed. There was a change in README, and there was one insertion in that file. And again, if we look at that file locally, indeed, we see that, yeah, there is our change that was first only available remote, now it's also local. So now we're in sync again. And we can start working on this file, we can commit it, we can push it, and it will be in the remote repository. This might all be very confusing right now, because there's a lot of commands that you need to get comfortable with, that you need to start understanding before you can comfortably work with all these with this version management. But it's a matter of doing this routine a few times, and then you know that's basically it's Git fetch, Git pull, Git status, Git commit, Git push. If you have done it 3 times, you already start understanding and be comfortable with using that. So try it a few times. I guarantee you will have lots of benefits from these commands to have automated version management on your files. Okay, so about collaborating, because that's a big thing, of course, when it's not, you know, just your archive and just your version control. You also want to use this probably to collaborate with other people. Now there's 2 ways of doing that. Usually what I simply do is use the settings in my my remote repository. Oops, those are not the settings I want, actually. Because my screen is, or because I zoomed in a lot, the button settings is missing here, so they put that under a drop down here. Normally it just says settings here, and you can click that, and in the settings settings view, you will see that there's also a item called Collaborators. And oh, I need to log in again. Okay, there we go. Under Collaborators, you can add people, and you can add them if you know their GitHub account. Then you can just add them as collaborators. What's your GitHub account?
CA Romein. CA Romein.
There you go. And if Annemieke would accept my invitation, she's now a real collaborator in my repository. And that means for a fact that indeed she can push and pull. So I granted a complete liberty to Annemieke to change my files and to copy them over and to destroy them. And I guess that the question that was posed in the chat is indeed related to that fact, because that doesn't feel quite all right. You want to be sort of course, you know, in control of your own data. So this is a very, you know, what to call that in English? So this is very, I guess, open way of sharing your repository. You regard yourself on equal footing and with equal rights with the collaborators. There's also a way to have people work on your data, but you are in control, and that's forking. And forking is something that actually you don't have to do. Other people, as long as they have access to your repository, can fork your repository. that means that they get their own complete copy of your remote repository. And they can change it, they can add changes, they can change files, they can delete files, etc., etc., etc. But that's all in their copy. It's not in your authoritative copy of the data and of the files. So if they want to suggest to you that you should integrate those changes, they do a pull request. And a pull request will result in you getting a mail or getting a signal in your account space that somebody is suggesting to integrate the changes that they made. You can review those changes, and when you decide that's indeed a good thing to have those changes, you can accept or agree to the pull request, and in that case, those changes are integrated in your repository.
Can you fork a private repository?
That is my question.
Yes, that should be possible, but I can't really tell you immediately how. So I should have to look into that, because I usually, basically all my repositories are public. But it should be possible to give people access to a particular private repository and still have them forking that repository.
I guess given the time and your other appointment, we should call it a day for now.
Yes. So just to round off, there's two ways of collaborating on the data in your repository, which is either making people direct collaborators or suggest to them to fork your repository and to have them send you pull requests for the changes they made. I do realize that, this is a lot of information. You have seen a lot of commands. We've been working on the command line, and this is all rather maybe confusing and a lot to take in. And that's why it's very useful, I guess, that this has been recorded, because it would be a good thing for if you want to start working with Git and GitHub as your version management and control system. You might want to reiterate the exercises or the hands-on examples that I gave on your own machine and try to get comfortable with those commands. Also, of course, me and Annemieke are prepared to answer any questions that you might have when you're trying to use these tools for version management. So I hope that was somewhat useful for you to see how Git and GitHub work together to support you with version control and management. Again, I can see that this is a lot of information, so I hope that the rerun of this recording will help you to get more comfortable with all the information. So thank you for your attention. And any questions? You're welcome. I realize, I do have another appointment rather back to back with